100. So drive is about 2-3 hours, right?
Yes, 2 to 3 hours.
Okay, okay. So no, yes, no, our Lampung University is located in the southern part of Sumatra. So we are about about 4 hours or 5 hours driving from our city to Jakarta.
Okay.
Yes, of course, by airplane it's only 45 minutes because we are in different islands, so we have to use ferry, ferry to cross,
Jakarta.
yes, our from Sumatra to Jakarta. Yes, actually, the distance is maybe about 300 kilometers, but sometimes we have to wait long time for the ferry.
Yes.
Okay. Now in Indonesia is rainy season. Yes, rainy season, and we have sometimes very high rainy day, heavy rain.
Here is winter. Now is the
Yeah,
15 degrees.
15. Okay.
Yes.
Now winter in Bangladesh. I know
Yes,
from
winter.
your coat. Okay. In my room now, I have to switch the aircon, air conditioner because very hot. Now in your country, you have to switch on the the heater.
We need heater.
Okay, okay. So now we have on not yet. Okay, maybe many members will join from 9:30, I think. So soon. Okay, any something to say, Dr. Sandi or Dr. Warji, to our invited speaker? He is very young, but he is already professor. He is my junior, so already professor. He was graduated. He graduated from Kyoto in 2015.
15 years.
2 years after me, but 2 years ago he got a professorship from Bangladesh Agriculture University. So, Omedeto, congratulations, Dr.
Thank you. Thank you.
So hopefully,
Congratulations, Mr. Anusir Rahman, Professor.
Thank you.
So hopefully we can cooperate. So you may extend, you may share your knowledge later, not only in the international lecture, but also maybe in the collaboration, research collaboration, especially in research collaboration. So hopefully the pandemic finish, and we can maybe we can invite you, not only you, but maybe also your students. Yeah, hopefully we can cooperate in the near future.
Yes.
Good morning, Mrs. Mahira Jari.
Oh, where's Mahira-san?
Good morning, everyone.
Oh, good morning.
Mahira-san.
Oh,
Hi.
Mahira-san, did you remember?
Of course, remember. How are you?
I'm fine. How are you, Mahira-san?
Good. I'm good. How about Lampung University members?
Yes. We
Yes,
are fine.
I'm fine.
Yeah.
Selamat pagi, Bu Evi Masito. Ya, Bu.
Alhamdulillah.
Oh, we have also Dr. Evi Masito from Gajah Mada University. Thank you, Ibu Evi, for your time joining this international lectures. We have our Vice Dean, Professor Purnomo. Assalamualaikum, Profesor Purnomo.
Waalaikumsalam. Selamat pagi. Good morning.
Selamat pagi.
Good morning.
Good morning.
Professor Purnomo, we have joined here Professor Dr. Anisur Rahman, our invited speaker from Bangladesh Agricultural University. Dr. Rahman, Professor Pranoma is our Vice Dean for academic
Nice to meet you,
affairs.
sir.
Yes.
Coba pakai head speaker yang bagus.
Yes, Professor Rahman, not only the participant is not only from Lampung, we have other members from and participants from Gajah Mada University, from Polytechnic Negeri Lampung, from IPB, from and also from UBM, UBM Malaysia. And also from Gifu University. One of our member is Cici Sugianti. So our faculty member, Cici Sugianti. Hello, Assalamualaikum, Ibu Dr. Cici.
Assalamualaikum warahmatullahi wabarakatuh, Pak Didi,
Waalaikumsalam.
Pak
Ya.
Profesor Purnomo, Pak Sandi. Selamat
Ya,
pagi,
Bu.
Pak.
Ohayo gozaimasu, Imam Ada.
Selamat pagi Bu Cici.
Pagi, Pak.
Selamat pagi Bu Cici. Ya, sehat ya Bu. Depan.
Alhamdulillah sehat, Pak.
Ya.
Thank you Ibu Cici joining.
Cici kok kurusan ya?
Ya, Pak.
LDR Pak, long distance. Lagi LDRan Pak. Aduh, kasihan ini. Ayo kita support supaya soon possible finish her PhD. Amin.
Pak
Amin.
Dimas,
Amin,
selamat
amin.
pagi. Selamat pagi Pak Dimas. Dari
We have also Dr. Dimas Firmanda Arija from Brawijaya Malang. Okay, thank you Malang joining also this lecture. Say something. Okay, Pak Dimas.
Assalamualaikum Pak Didi.
You know him, Dr. Anisur Rahman. Okay. We have
Berapa ya kemarin ya?
5 members here from Kyoto. Okay, it's very nice. And also from Unsri. Thank you
ada-
Ibu Hilda Agustina from Unsri,
Ya, ada mic-nya ini.
University of Sriwijaya. Yeah. So I think many participants from not only from Lampung, from other universities also joining this lecture. Okay, waiting for the other participant joining this lecture. Maybe if you have something to say hello to Dr. Anisur Rahman. So Professor Anisur Rahman is a very young researcher, but he is very active. Now, in last 2 years, in 2020, he already got a professorship from Bangladesh Agriculture University. So his expertise is very well known in the spectroscopy and hyperspectral society. So you may later after this lecture share and maybe yes.
Ada mereknya ini, Logitech. Ada mereknya Logitech.
Bagus tuh ya. Ya, itu bagus.
Ya. Kalau yang terlalu tebal aku nggak suka.
Ibu Epi
Blok gitu. Nah, itu.
from Gajah Mada University.
Ini
Maybe
masih
you
agak-
can say hello.
Kalau yang tebal rapet telinganya kan nanti ada suara dari luar kadang-kadang nggak.
Tutup ya.
Udah tak tutup.
Okay, from Gajah Mada and also yes, our students also joining. Oh, we have also Professor Ainin Niswati. Assalamualaikum, Professor Ainin. Thank you for joining this lecture. She is one of our faculty member, professor in soil science. Thank you for joining, Ibu Ainin.
Morning.
Okay, thank you, Ibu. And also, yes, thank you to
Join seminar international lecture.
okay, yeah. Thank you, Professor Ainin, Ibu Ainin. Thank you, thank you. This is the first lecture. Hopefully, we can yes, maintain this and keep to hold these international lectures every month, hopefully. So we invite many researchers, top researchers from
Overseas.
many universities abroad, especially in Asian countries.
Mhm.
So actually, last year we have invited three inspiring guest lecture from three Asian countries representing different regions from Southeast Asia. Dr. Mahira here is the first presenter, the first guest lecture. And then the second one is from China, so from East Asia. And then the last one in 2021, we have Dr. Jia Jiasan. She is from China, from Dalian University of Agriculture and Technology. So from East Asia. So now from South Asia. So now our guest lecturer is from South Asia. Dr. Rahman is from Bangladesh Agriculture University. So hopefully this international lecture representing the many different regions from Asian countries to support our future to provide enough food for the next 2 million coming people up to 20 and 50. Okay, Dr. Warji, maybe we can start or not yet? Dr. Sandi?
Okay.
Oh, wait a moment, Mr. Didi.
Yeah, also we have from IPB, Ibu Handayani. Thank you for joining this lecture. And thank you for Mr. Muhammad Anwar Hussain. Maybe you are from Bangladesh. Thank you for joining this lecture. We have also our former head of department, Professor Dr. Agus Haryanto. Dr. Agus Haryanto, good morning. Thank you for joining this international lecture.
Good morning, Pak Diding.
Okay,
Good morning,
thank you,
everyone.
Pak Agus. Okay, please be patient. We are now waiting for the other members to joining this lecture. So soon we will start this international lecture. And we already shared the virtual background for this international lecture. So you can see on the chat box, you can easily download the virtual background. And of course, you may use the virtual background for this international lectures.
Can anyone hear me?
Okay. Go ahead. Okay.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. First of all, I would like to say welcome to our Honorable Vice Dean of Faculty of Agriculture, Lampung University, Mr. Professor Dr. Insinyur Purnomo MS, the Honorable Mr. Professor Dr. Anisur Rahman as the guest lecturer, the Honorable Mr. Dr. Insinyur Sandi Asmara MSc as the Head of Agriculture and Biosystem Engineering Department, the Honorable Mr. Dr. Diding Suhandi STPM Ager as the moderator, and the honorable participants. Ladies and gentlemen, welcome to the International Lecture on Agriculture and Biosystem Engineering, with the theme Quality Assessment of Agricultural Products using Vibrational Spectroscopy and Hyperspectral Imaging Techniques. It's a great honor. My name is Krishna Bayu Aji, will be your master ceremony for this extraordinary event. Ladies and gentlemen, before we begin, it would be nice for us to pray, so this event will run well from the beginning until the end. We invite all attendants to join the prayer according to respective religions, and the prayer begins. Finish. Well, now we would like to introduce you to the Head of Agriculture and Biosystem Engineering Department. So please welcome Mr. Dr. Insinyur Sandi Asmara, MSc. Time is yours.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Tabi pun.
Ya
Good
pun.
morning to all of you. Alhamdulillah, praise to God, the Almighty. Your Excellency Professor Dr. Anisur Rahman, invited speaker from Bangladesh Agriculture University. Your Excellency Professor Dr. Irwan Sukri Banua, Dean of Faculty of Agriculture, University of Lampung. Your Excellency Professor Dr. Purnomo, Vice Dean of Academic and Cooperation Affairs, Faculty of Agriculture, University of Lampung. All faculty members, students, alumni, and ladies and gentlemen, the participant of the International Lecture on Agriculture and Biosystem Engineering. Welcome to Lampung. Welcome to Department of Agriculture and Biological Engineering, Faculty of Agriculture, University of Lampung. We are happy and very honored to host you all in this current international lecture. The main intention of the international lecture on agriculture and biosystem engineering as in our department is to provide an international academic atmosphere in our department and our university. This international academic atmosphere is very important to elevate our university reputation in global higher education. This lecture also will promote strong international research collaboration in our university. We believe that it will be a great contribution from our department to elevate our university accreditation. We plan to hold this international lecture monthly. Today is the fourth international guest lecturer, and Professor Dr. Anisur Rahman is one of the key persons in pump, power, and machinery Bangladesh Agricultural University, Mymensingh, Bangladesh, will give us an important lecture on quality assessment of agriculture products using vibration spectroscopy and hyperspectral imaging technique. Next month in February, our department has got an agreement with guest lecturer from Taiwan, and we also plan to invite many experts from Japan and other top university to be our next guest lecturer. I hope not only our students, our faculty members, but also our alumni will enjoy this international lecture. Finally, our department would like to thank the Dean Faculty of Agriculture, the University of Lampung, for their continuous support for this event. On behalf of the department, I ask our Dean to officially open this international lecture. We wish you all have a fruitful and productive lecture today. Thank you very much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Warahmatullahi wabarakatuh.
Thank you, Mr. Dr. Insinyur Sandi Asmara MSc, for the great speech. The next agenda is delivering speech that will be delivered by the Vice Dean of Agricultural Faculty, Lampung University, Mr. Professor Dr. Insinyur Purnomo MS. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Morning. Alhamdulillah. Praise to God, the Almighty. Let me represent the Dean of the Faculty of Agriculture, University of Lampung, Professor Irwan Sukri Banua, to give speech and open the international lectures at the Department of Agricultural and Biological Engineering. Your Excellency, Professor Anisur Rahman, invited speaker from the Department of Farm, Power and Machinery, Bangladesh Agriculture University, Mymensingh, Bangladesh. This name like Bogor Agriculture University, yeah, BAU. Yeah. Your Excellency, Dr. Sandi Asmara, Head of Agricultural and Biological Engineering, Department, Faculty of Agriculture, University of Lampung. All faculty members, students, ladies and gentlemen, the participant of the international lectures this morning in Agriculture and Biosystem Engineering. Welcome to Lampung. Welcome to the Faculty of Agriculture, University of Lampung, UNILA. We are happy and very honored to host you all in this current international lecture. I am very happy to report that the international lecture on agriculture and biosystem engineering have been well conducted 3 times last year. In this international lecture, our university invited many experts from Asia with different regions to share their advanced knowledge. The invited speakers from Malaysia, Southeast Asia, China and Japan from East Asia delivered very interesting and inspiring lecture last year. In 2022, in this month, I'm very happy to support the 4th international lecture held by the AB department. And in this 4th guest lecturer, Professor Anishur Rahman from Bangladesh. Professor Anishur Rahman will share with us the quality assessment of agricultural products using vibrational spectroscopy and hyperspectral imaging techniques. As we know that in 2050, it is expected about 2 million new population is coming. Most of them are in Asian countries. For this new population, we have to provide enough food with high quality and safety. However, it is reported that food loss and food waste in Asian countries are still high. In this note, more than 10% on average. The use of advanced technology, including vibrational spectroscopy and hyperspectral imaging technique, may help us to reduce food loss and save food better. Finally, this technology may help us to provide food in enough quantity and in the best quality. Finally, I hope this international lecture will promote academic exchange and international cooperation between the two institutes of UNILA and BAU, Bangladesh Agriculture University, in the near future. The purpose of the cooperation is to establish long-term scientific and technical cooperative relationship, including mutually academic collaborative research and the exchange of information, techniques, and publications. Ladies and gentlemen, by the name of Allah, the God Almighty, I hereby officially open the international lectures on agriculture and biosystem engineering. We wish you all have a fruitful and productive lecture today. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Mr. Professor Dr. Insinyur Purnomo, MS, for opening the event and the great speech. The next is delivering lectures that will be led by our moderator. He was an undergraduate student of Institut Pertanian Bogor, master student of Kochi University, Japan, and Doctor of Biosystem Engineering in Kyoto University, Japan. Also, he has plenty of achievement. He has published 27 journals, which the latest one is Journal of Engineering, Science, and Technology, with the title is The Use of Ultraviolet or UV Spectroscopy and Seismometrics to Quantify the Percentage of Adulteration in Colosic ground, processed specialty coffee. That is published on February 2021, and also he has published 5 books. Well, please welcome Mr. Dr. Diding Suhandi, STP MAGR.
Okay, thank you, Master of Ceremony, for the very nice introduction. Ladies and gentlemen, may I have your attention, please? So this is the fourth lecture, the fourth guest lecture. And I'd like to remind all you that the participant during the lecture, the host will mute all of you. And after 1 hour presentation, we will have a question and answer session for another 1 hour. And for that, please ask your question by using a chat box. You can write in the chat box, or maybe later you can raise your hand and directly deliver your question to the our guest lecture. Okay, first of all, Honorable Dean Faculty of Agriculture, University of Lampung, Professor Dr. Insinyur Iwan Supri Banu, MS. Honorable Vice Dean of Faculty of Agriculture, University of Lampung, Professor Dr. Insinyur Purnomo MS. Honorable Vice Dean of Faculty of Agriculture, University of Lampung, Dr. Aman Damai. Honorable Vice Dean of Faculty of Agriculture, University of Lampung, Dr. Kuswanta Putas. Honorable Head of Department of Agriculture and Biological Engineering, ABE, Faculty of Agriculture, University of Lampung, Dr. Sandi Asmara. And of course, Honorable Professor Dr. Anisur Rahman, our invited speakers from the Department of Farm, Power and Machinery, Bangladesh Agriculture University, BAU, Mymensingh, Bangladesh. And distinguished guests, ladies and gentlemen, and of course our beloved ABE students, good morning and Assalamualaikum warahmatullahi wabarakatuh. First of all, I'd like to welcome you all to this fourth guest lecture of the International Lectures on Agricultural and Biosystem Engineering. As reported by our Vice Dean, so last year we have invited 3 inspiring guest lectures, and today's lecture is the first international lecture for 2022. So before the presentation begins, allow us to introduce our guest lecturer today. So Professor Dr. Anisur Rahman is now a professor, a full professor at the Department of Farm, Power and Machinery, Bangladesh Agriculture University, BAU, Mymensingh, Bangladesh. He completed his master's degree in 2010 from Bangladesh Agriculture University and PhD in 2015 from Kyoto University. So just 5 years after completing PhD, he got a professorship from Bangladesh Agriculture University. So he is very active in research. So he has much interest, especially in the development of precision agriculture for smart farming system using several advanced technologies, including vibrational spectroscopy, acoustic technique, and of course, hyperspectral imaging technique. He is now one of the young top researchers, very young professor, and has very active research with his group on vibrational spectroscopy and its related research. So it is a great pleasure for us to study with him about the quality assessment of agricultural products using vibrational spectroscopy and hyperspectral imaging technique. Okay, finally, without further ado, I'd like to welcome our guest lecturer, Professor Dr. Anisur Rahman, to deliver the presentation. The title of the lecture is The Quality Assessment of Agricultural Products Using Vibrational Spectroscopy and Hyperspectral Imaging Technique. Professor Rahman, the screen is yours.
Thank you very much. It's okay?
Okay, okay.
Assalamualaikum. Happy good morning.
Waalaikumsalam.
And Happy New Year.
Okay, you too.
At first, I'd like to thank Diding Swani and Department Head of Biosystem Engineering, Agriculture and Biosystem Engineering. Also, I would like to thank Vice Dean Purnomo to invite me for this guest lecture. In this lecture, I want to talk about the quality of food, the agriculture product, like the agriculture fruits, vegetables, the quality assessment using the vibration spectroscopy and hyperspectral imaging technique. Mainly, I will focus on the NIR spectroscopy and hyperspectral imaging technique. I will talk about data analysis and I will show some application. Here, the presentation content, what I will be covering in this presentation. Firstly, I will tell my country, my university, and myself the necessity of agriculture product quality assessment, why it's needed. Then vibration spectroscopy technique, how it's work. Then near infrared spectroscopy and sensing mode. Then hyperspectral imaging, configuration of hyperspectral imaging, hypercube, general step of hyperspectral imaging process, prediction map. Final data analysis, some applications. And final slide, I will talk some challenges in the future work about the hyperspectral measurement. What is the challenge in this field? Bangladesh, this is the flag of Bangladesh. Like in Japan, we have the only white and our is the green. This is the flag of Bangladesh. We are situated in the South Asia. Our neighbor countries, India and Myanmar. And other side is the sea. And we independence of Pakistan 1971. So 16 December 1971, we independence from Pakistan. Our father of nation, Sheikh Mujibur Rahman. And our capital is the Dhaka, the central part of my country, Dhaka. And our area is the 148,000 square kilometers. And only 6.4% is the water body, most of that is the land area. We have only hilly area in 3 districts, the little part, only 1% land is the hilly area. Mainly our land is the plain land and suitable for the paddy cultivation. In population, we have the huge population, around 164 million people, and gross domestic product GDP are the 409 billion USD, per capita is the 2,554 US dollar. And our GDP in agriculture contributed only 14.2%. This is our famous person, Nobel Peace Prize winner 2006, Muhammad Yunus. We say Professor Dr. Muhammad Yunus. He is the Nobel Peace winner. We have a 6 seasons, the summer, rainy, winter, autumn, and spring. Now is the winter season. Yeah, but our winter is the lowest temperature around the 10 degrees Celsius, and in summer is highest the 45 degrees Celsius. Now in my university, Bangladesh Agriculture University, is the oldest university in my country. The first agriculture university in Bangladesh is situated in 1961, and the third university before independence. Dhaka University, then this university. It is located 120 kilometers north from Dhaka. And the area of the university, 1,200 acres. We have a 6 faculty, 44 department, undergraduate degree offer, only 8 degree offer from this university. This is the faculty of our university: Faculty of Veterinary Science, Faculty of Agriculture, Faculty of Animal Husbandry, Faculty of Agriculture, Economics and Rural Sociology, Faculty of Agriculture, Engineering, Technology, Faculty of Fisheries. I belong to Faculty of Agriculture, Engineering, Technology, where the department is the 5 departments. Every year, 1,200 students admitted in this university based on their 12th grade result and other qualities. Here, the good news is that the Time Higher Education World University Ranking is world ranking is the 1001 to 2000, but in Bangladesh Agriculture University, in Bangladesh is the 2nd university, and the Life Sciences, it is 1st university in Bangladesh, and world is ranking is the 601 to 800 in Bangladesh Agriculture University. That Times Higher Education World Ranking, the famous ranking. Now Faculty of Agriculture, Engineering and Technology, where I belong to. Here are the 5 departments: Farm Power Machinery, Irrigation Water Management, Farm Structure and Environmental Engineering, Food Technology and Rural Industries, Computer Science and Mathematics. Here, the Farm Power, from this faculty, we offer the 3 degrees. One is the basic agriculture engineering degree, BSc in food engineering degree, BSc in bioinformatics engineering degree, the new degree. These 3 degrees offer from the Faculty of Agriculture, Engineering and Technology. Among them, Department of Farm Power Machinery is the largest department of the faculty. Total number of faculties is the 9th. Most of them got the PhD from the abroad, the USA, Europe and Japan. Major field area in this department is the design of agriculture machinery, renewable energy, biosensing, precision agriculture, post-harvest technology, and agriculture mechanization. this department is the pioneer in our country for agriculture mechanization, solution, and design of agriculture machinery. This is the oldest department. Like if you say the in Bangladesh agriculture engineering and farm power machinery and mechanization, you must say to our department name, farm power and machinery, and our university. This is the oldest university and the only one university before 2000 for agriculture and agriculture engineering technology. This is the myself. Now I am working in the university, Bangladesh Agriculture University Department of Farm Power Machinery as a full professor from 2020. And my research and teaching experience 12 years almost, and areas part is mainly machine visual spectroscopy, hyperspectral imaging, number of publications 31, mostly in abroad in journal, impact factor journal. And my professional experience, like I spent 2 years in Zhejiang University, China, the world ranking university for my postdoctoral research. I was working as the Chungnam National University, South Korea 2 years. I got my PhD 2015 in Kyoto University, same as the Diding Suhani got the PhD, awarded the PhD. I was a visiting scholar, University of Saskatchewan, Canada for 6 months. This is my OTIT ID. I am not going to the details about my anything. Now let's go to about the main things, necessity of a quality assessment. Why we need quality? In food, we have a food quality, food safety, food security. Here, I only will talk about the food quality, not food safety and food security. I will talk about the food quality. If you go to market, you want to the quality foods, quality product. How buyer consumer demand the quality agriculture product? Because product quality is the combination of all characteristics like the appearance, flavor, texture, and internal quality. Buyer want to pay more money for the quality food. Like you go to market to buy the one banana, you want to pay more if it is quality, good quality. So increase expectations for quality agriculture product because demanding accurate, fast, and objective quality determination. People want, okay, this food is good, this food is bad. This food contain the high sugar content, this food contain the low sugar content. People want to know and want to pay more money for that. Now is this traditionally involve human visual inspection. People, the quality determined using the human inspection. This is tedious, laborious, time consuming, and inconsistent. So what we want in recent years, spectroscopy and hyperspectral imaging has been regarded smart, promising analytic tool for analysis agriculture product quality. If you want to quality product, now spectroscopy and hyperspectral imaging is a promising non-destructive tool for measure the quality. Because it advantages the non-destructive, rapid, no-need chemical reagent, and cost-effective method for quality assessment. Like vibration spectroscopy technique, one of the techniques used for the measure the quality of the food is inside the structure and chemical composition of the sample. Chemical composition of the sample by measuring the intensity and spectral distribution of light emitted by sample. Mainly focus on the vibration spectral structure and chemical composition of sample by measuring the intensity and spectral distribution for the intensity and spectral distribution of light emitted by the sample. Vibration spectroscopy technique, mainly we have a NIR, Raman spectroscopy, hyperspectral imaging, FTIR used as a sensitive and fast analytical tools for quality analysis for agri product. This is the sample. If you use the hyperspectral imaging light and the sample, we will get some images and some spectra. Also, in a spectroscopy, you can use sample, you have a detector, you have a light, you will get one kind of spectra. In Raman, you have a laser light, you have a detector, you will get some response, intensity response, Raman scattering. But Raman spectroscopy mainly used for the food adulteration and pharmaceutical product. In this lecture, I will not cover the Raman spectroscopy. Mainly, I will focus on hyperspectral imaging and NIR spectroscopy. Here, NIR spectroscopy mainly associated with the molecular vibration, especially overtone and combination of fundamental vibration. Here the sample, if you light emitted, the molecule is have a vibration and emitted the some sensitivity to light with different wavelengths in terms of light absorption. Chemical bonds between the CH bond, OH bond, and NH bond generally high vibrational frequency, which result in overtone and combination band that detectable in the NIR region. NIR region, we say the 782 2500 nanometer. This is the NIR region. Record the intensity information, this intensity information, light intensity, absorption intensity information of this molecule over corresponding wavelength. Then if we get the intensity corresponding wavelength, we get some information about the molecule, atom, and then the chemical composition. The NIR spectroscopy mainly used for chemical properties like SSC, acidity, moisture content, etc., and internal defects of agriculture product. If you want to see, okay, I want to measure the internal quality of fruits, like this is bad or good fruits, then we can use the NIR spectroscopy to measure this fruit is good or bad. We need to remember that NIR spectroscopy mainly work with the molecular vibration, especially the overtone and combination of fundamental vibration. There are the sensing mode, how to sense the NIR spectroscopy. There are different methods. There are the reflectance. We know reflectance, the two types, specular and diffuse. Diffuse and specular reflectance. Mainly, the differentiate is that this is the A figure. You can see line of lamp and detector is the same place over the sample. If light source place over the sample, the light source and detector place over the sample is the reflectance mode. And transmittance mode, the detector and light source position in opposite side of the sample. The light source and detector mainly opposite sides. The light source the up and detector is the opposite sides. And interaction mode, the detector and light source are positioned the same set of sample with certain source detector separation. Detector and light is the same side, only slightly distance they maintain for the some physical materials. The mode of the sensing mode depends on mainly type, physical properties, characteristics of the sample. If you have a shiny sample, if you have a hard, like you want to measure the internal quality of some nut, but the covering, outer cover is too thick, it is very difficult to use the transmission mode. So people use very difficult to use the reflectance mode. You need to find out the sensing mode, which mode is the good for collect the data. This is the mainly depends on the type, physical properties, and characteristics of the sample. Which product you want to measure and what you want to measure. It depends on these. The selection of mode depends on these types, physical properties, and characteristics of the sample. Before the experiment, we need to think about, okay, this is the sample is the apple. We want to measure the internal core. So what type sensing mode we use? But if you want to measure the sugar content of the apple, it is easy to reflectance mode. But if you want to the internal core, internal quality, internal defects, then you need to transmission mode. It depends on your sample and what you want to measure. Now, hyperspectral imaging technique. Hyperspectral imaging, only the conventional imaging and spectroscopy. The image and spectroscopy, this is the combination, is the hyperspectral imaging. It's collecting the both spectral and spatial information from objects simultaneously. Like on apple, you will take the picture and same time you will take the image and the spectra. This is the hyperspectral imaging can generate. The main advantage of the hyperspectral imaging, it generates a chemical map to distribute the parameter of interest. This is the left side, the figure. You can see some X and Y, there's a spatial dimension, and the lambda is the spectral dimension. These are three dimensions we will get from here. One is the image, another is the spectra. Mainly application is the physical and chemical properties of agricultural product. The hyperspectral imaging have some advantage for beyond the spectroscopy because it records a spectral volume that contains a complete spectrum of every spot. But whereas single spectrum at a spot recorded by spectroscopy. If you use NIR spectroscopy, it will only the spot, a single spot, you will get the spot spectrum, not the whole body, whole fruits. So this is the one advantage, the recorded spectral volume that contains a complete spectrum for every spot, whereas a single spectrum at a spot recorded by spectroscopy. Flexibility is choosing any region of interest in the image even after image acquisition. You can select, okay, I will take this region the spectra and I will take this region spectra. You can select after image acquisition. Able to determine the several composition simultaneously in the same sample, like moisture content SSC, you can measure, allow the visualization of different biochemical present in the sample based on the spectral signature. You can show the prediction map or chemical map to show the different chemical components in the sample. Allow many different objects detect and distinguish even similar color morphology and overlapping spectra using the hyperspectral imaging. But it has some disadvantage. Contain a substantial amount of data, huge data, because on sample in NIR spectroscopy only you will get the spot information, but hyperspectral imaging you will get the whole information, whole body information, whole surface information. It include more redundant data, more data. It takes long time image acquisition analysis. For spectral, take the image acquisition analysis take the long time. Very directly implemented online system for automatic quality evaluation. And it's very difficult to apply directly in online system for automatic quality evaluation purpose, hyperspectral imaging system, because it takes the long data, many data and image acquisition and analysis take long time. So directly online system is very limited to use. Indirect methods, which means it's needed standardization, calibration, and model transfer procedure, not suitable some cases, such as liquid and homogeneous sample. Hyperspectral imaging is not working good well. So what we'll do is take the lot of data and take the image acquisition analysis lot of time. So we need to take the analysis and hyperspectral imaging data, select the few effective and suitable wavelength for imaging system. Then you can apply for the online system. Select a few effective and suitable wavelength for imaging system. Now some fundamental of hyperspectral imaging system, how to configure, how to take the data and what is the. This is the one kind of hyperspectral imaging system, the Wiggs boom or point scan. It scans only point of the sample. Then it's move one by one. It take the only point scan. Then another is the push boom or line scan. It scans the sample in line. The sample is moving and it take the data is a line. And this is the area. The scan entire sample in wavelength at a time. If the sample is steady, not moving, and it take the area scan. This is the single shot, scan entire sample within one exposure. It takes little small time, only one scan, the whole sample. Mainly in laboratory purpose, we use the push boom and line scan is the use mostly for scan the sample in consecutive line for the precision work. On hyperspectral imaging instruments, and what we will get from there. On light source, on conveyor belt, the sample is moving because it's the line scan, it's only line scan. On line by line, we'll scan the sample. On spectrograph, on camera, lens, conveyor belt, and illumination unit. illumination unit, and this is the one setup. You need to these components for one hyperspectral system, but the setup may be defined based on your objective. Like here, you use the illumination unit, direct illumination unit, direct lighting system for Apple, and the camera lens, spectroscope, and camera take the data for hyperspectral data and computer and image recognition software here. And this is the conveyor belt. The sample is moving for line scan, for area scan, for point scan. This is the one. What is the hypercube? Hypercube from hyperspectral data, we will get the three-dimensional data. One is the X, Y, the spatial information, and Z is the spectral information. This is the three-dimensional with two spatial coordinate, and other is the spectral value. Collective image, one stack for all wavelengths are same as the conventional digital image. You can say digital image or image. Like here on picture, the wavelength is the 400 to 1000. The image is like that, and spectra is like that. The RGB image, the RGB image, then the image is the 1000. The hyperspectral, you will get the only one image, like hypercube, the right side image you can see. Okay, right hand image you can see. X and Y is the spatial coordinate of the image, how much length and width of the image, and the Z, another is the spectral dimension, the lambda, spectral dimension. If you want to use, like this image, the 400 to 1000 nanometer. If you want to use the 600 nanometer, you need to collect the 600 nanometer wavelength image, spectral dimension. Each spectra, you will get the image. This is the hypercube. This contains a lot of data. General state for hyperspectral imaging process, how to process the spectral image. First, spectral image acquisition, then calibration. You need to calibrate the hyperspectral image because you need to calibrate the white reference and dark. Then image segment, region interest, what you want to, which region you want to use for data collection, like spectra collection. This is the image acquisition and pre-processing. Then extraction data treatment. If you select the region of interest, then you go to the image selection. Which image, it's specific wideband, which image you needed. Like if you want to measure the external bruishing, Apple, like external bruishing, you can see the 600 nanometer is the higher intensity. You need to select that image. Then dimensional reduction, spectral extraction, spectral extraction, model calibration, model validation, and visualization. This is the general process for hyperspectral imaging analysis. I'll go another is the sample image. You need to image correction. How to image correction? Image correction is the raw sample spectra data and the dark current spectrum and white reference spectrum. You need to correct it image, the calibrated image. You need to first calibrated image to check the hyperspectral imaging process. Then you need to two parts on the image analysis and on the spectral analysis. Depends on your objective, what you want to measure. If you want to measure, okay, outside bruishing, so image analysis is okay. But if you want to internal quality, then you need to spectral and image both. Here the spectral analysis, you need to spectral extraction, pre-processing, model calibration, model validation, simplified model if you want to. Then image analysis, selected image, pre-processing, feature extraction, calibrate model, validate model. You can model application, finally prediction map. I will show in my application how to process the hyperspectral imaging and prediction map. This is the prediction map. This is the Mango, TDSS, TA, and firmness. Show the day 1, day 4, day 6, day 8. The day 1, the firmness is the high around the 30 firmness, and the day 8 firmness is the low 5.06 only. TA titratable acidity. The TA titratable acidity is the Suitable acidity is the first, the low, and the final day 8 is the high. TSS, the first is low and final product is the high. Suitable acidity is the first is high because the acidity is high, then last day 8 is the low. And hyperspectral imaging, this is the main advantage. You can show, okay, this mango, this part is too, this part is the very sweet, this part is very sweet, this part is very, this part is not good. You can select the whole body, you can check the difference of the chemical composition. This is the main advantage of the hyperspectral imaging. Visualization of different biochemical constituents presented as sample based on their spectral signature, because region of the same spectral property should have similar chemical composition. So if you want to sell the big mango, then you can slice. Okay, this is the good TSS, this is the bad TSS you can eat, and this is the high price, this is the low price. So from this prediction map, you can easily understand this area is the high firmness, this is the low firmness area. This is the high sugar content, this is the low sugar content area. You can easily compare from this figure. This is the main advantage of the hyperspectral imaging system. So data analysis, the spectral data analysis. I will talk about some spectral data analysis, how to analyze the spectral data, what the condition you need to think. First, you need to think of the selection wavelength range. What wavelength you want to measure, you want to analyze. The full range, partial range, selected range. Depends on your objective, depends on your data quality. Like some spectra contain the high noise, you need to remove this one. So you need to select which region you want to use. Full range, partial range, selected range, depends on your objective. Then usually we did the pre-processing of spectral data. We have a different methods, smoothing, scattering correction, differentiation, some methods for smoothing, pre-processing the spectral data, because spectral data contain noise and other overlapping data. So we need to pre-processing spectral data. Then finally, we need to go to selection and analysis of regression and classification model. Depends on your objective. What you want to do, classify or your regression. If you want to regression, we have a different method, multiple linear regression, principal component regression, partial square regression, forward vector machine regression, artificial neural network regression. You have some classification method, PLSDA, SIMCA, KNN, LDA, some classification model. It mainly depends on your objective, what you want to do. You want to classify the good, bad, or you want to prediction something, prediction how much sugar content, how much TA. You need to find out what you want to do, regression or classification model. Depends on your objective. Evaluation model, we have some criteria to evaluate the model, like R square error predictions, RPD, RE, sensitivity, specificity, accuracy. And finally, if this value is good, you need to select the final model. If not, you need to pre-process the data and you need to find out the regression model or classification model again. If your model is good, you need to apply in real life. So now we will go to pre-processing data, spectral data. Why we do pre-process the data? Main reason for spectral data pre-processing: remove the physical phenomena in the spectra in order to improve the robustness, accuracy of sufficient quantity of classification model. Mainly remove the physical phenomena in the spectral data to improve the interpretability, raw data, better understand format, to detect taints and remove the outlier from spectral data, to reduce the dimensionality of the spectral data. Mainly improve interpretability, raw data to better understandable format, detect the trends and remove the outliers from spectral data. Also to reduce the dimensionality of spectral data. We mainly done the spectral space processing for this reason. And we have a lot of methods, mainly smoothing method, moving average, one method, subscriptural smoothing, Fourier transform, Bosca averaging. We have scatter correction method, normalization, multiple scattering correction, standard normal variate, extended multiplicity scattering correction, detecting. We have another is the spectral derivatives, subscript polynomial derivative filter, Norris-Williams derivatives. We can use the method to pre-process the spectral data. The methods depends on your objective, what you want to measure, what you want to get from spectral data. And you need to check the different spectral pre-processing method, which is the good for your model preparation. We have known thumb rule, okay, this method is good for this method good for this. You need to check and balance. You need to check, okay, this is good, this is bad, this is good, this is bad. And finally, you need to find out the good method for data analysis, pre-processing technique. We have a classification model. If you want to classify, like this is good, this is bad, this is 10%. If you want to classify, you have mainly two methods. One is the supervised classification method, another is the unsupervised classification method. If you go to supervised classification method, this supervised classification method, sample are classified without period knowledge. You don't know this is this viable or this is not viable. You don't know. You need this classification method is clustered the sample based on their tendency. Without period knowledge, and supervised classification model are technique in which period knowledge, like you need to identify, okay, this is the good, this is the bad, this is the good, this is the bad. You need two category membership of the sample before model preparation, like LDA, SIMCA, NNA, PLSDA, etc. We use mainly supervised classification method, but if you want to use the actual condition, it is better to use the unsupervised classification model because it's classified based on the trend of the data. Another, we have a regression model. Regression model wants to building the relationship between the desert physical, chemical, biological activities of object and spectrum response. Like if you want to prediction, if you want to do any prediction like sugar content prediction, if you want to touchable electricity prediction, firmness prediction, you need to go regression model. We have a two-kind regression model. One is the linear regression, another is the non-linear regression method. Like PCR, principal component regression, PLS, partial least square regression, MLR, multiple linear regression. And non-linear, we have a lot of methods, least square, support vector, machine regression, etc. And question, which regression method is better one based when compared to others? How we will say this regression method is good, this method is bad? It depends on compare the result among the developed model and decide. You need to make a model, all regression methods, then the best result will go, then you will compare. And the best result, the regression model is good for your objective. So we have no thumb rule. Okay, this is the regression method. You need to use for sugar content measurement this regression method. We cannot say this one. We need to compare the result among the developed model and decide which method is good. There have no thumb rule for regression methods and pre-processing methods and the classification method. So how to compare the result? How we will say this is the result is good, this is the bad. So we have some criteria. The regression coefficient for calibration, regression coefficient for prediction, root mean square error, correction root mean square error of cross validation, root mean square error of prediction. We have this. If this value is the value range is the 0 to 1, if it is near to 1, it is good. Higher is good. Higher is good, and lower is good. Near to 0. But sometimes if value is maybe overfitted, you need to check also this one. Your model is overfitted or not. If the regression coefficient is 1, calibration 1, prediction 1, this is 0, 0, 0, this is overfitted model. So you need to check your data. This is maybe something happened in your data. This is overfitted model. Here, another some criteria to judge your evaluation model, mainly RPD, RE. If you want to judge the RPD, RE, ratio prediction deviation, ratio error range, you can measure, and for the online application, this two value is now scientific world is well accepted. For classification model, you can judge the confusion matrix generally build the summarize the classification result. The prediction sample, actual sample. The positive, both are, your actual sample is the like positive, like good. The prediction also good, the A. But your actual sample is the positive, but your prediction is the negative. This is the B. Like you need to make a confusion matrix. From the confusion matrix, you can measure the specificity, sensitivity, precision, accuracy using this equation, and you can say, okay, this higher the value is the good, and you can say, okay, this is the good model, and this is the good experimental result. So up to here, I told some basic information how to build a spectroscope. I discussed about the spectroscopy, have a spectral imaging, some fundamental of high spectral imaging, regression method, classification method, how to evaluate the regression and classification method. Now I will show some two applications. One is the NRS spectroscopy, another the hyperspectral imaging. Two are published paper from my previous research work. One is the intake macadamia nut quality assessment. You know macadamia nut? I don't know, you know macadamia nut or not. This is the macadamia nut. The picture shows the macadamia nut. The outer shell is very thick. Inside is the nut material which we will consume. But quality of macadamia nut depends on two parameters: percent of oil content and unsound kernel. Here you can see the picture, some unsound kernel, some rancidity, some bad kernel. But from outside, it is very difficult to check, okay, this nut is good or bad. Very difficult to judge. Also the oil content, because this is the oil content, you can, the outer shell is very thick. It is very difficult to penetrate light inside the sample to check. So we use some technique here to measure this one. It is published paper is a food composition and analysis imperfector about the four imperfector. Quality of macadamia nut depends on mainly two parameters: percentage of oil content and unsound kernel. The traditionally sorting of macadamia nut skill worker based on color and visibility information cannot judge the internal defects. They cannot judge the internal defects. And also internal quality does based on percentage of oil content, which cannot be detected by manual method. Common disadvantage because inaccuracy is slow and require an expert, use chemical and destructive, costly and evaluative for nut quality in industrial scale. So demand rapid accurate real-time in situ system or quality evaluation. Here we use we understand the objective classify internal defects and predict oil content of intake macadamia nut, intake macadamia kernel. Using portable NRS spectrum, we take integrating sprayer. We use here integrated sprayer to collect the data. This is the main sample for my experiment. This is the outer layer, you cannot see. This is the bad or good, the sample. We use the 342 matured intake macadamia nut in this experiment to check this is the good or bad sample. This is the experimental setup, how we measure the sample. Here we use the 150 watt halogen light, the high intensity light. If you keep the 30 seconds or more than 45 seconds, the surface of the nut is burned. So this is the high intensity light. We use the colorimeter to concentrate the light into the some path. The sample, this is the integrated sprayer. We put the four spectra. We take four spectra from different equator of intake macadamia nut acquired in the 3.0 nanometer increment with 400 microsecond integrated time. Within 400 microsecond, we take the data and light source, and we'll mount the 180 degree compared to the sample and integrated sprayer. We put the sample here and take data. Reference below after spectral data collection, each macadamia nut sample will unshelled first, then visually sorted based on the kernel quality defects. Good kernel without defect. This is the good kernel. Bad kernel, defects with distortion, immature kernel affected by mold, and kernel with insect damage. This is the bad kernel. After internal defects evaluation, each defects will label for the further classification model development. This is the supervised classification model we use in our study. Each defect will label for the further classification model. Percent of oil content measurement, we use the oil content extraction known mass of the dry kernel sample using the hexane as a solvent, after which the oil yield oil calculated. The well-established method, we have the oil content measurement. We use the reference method for oil extraction method to measure the percent of oil content of each nut. Data analysis due to the spectral data content random noise and spectral variation. So pre-processing needed. Before that, we say essential. Here in our experiment, we use the substitute first and second order derivative, multiple scattering correction, or standard normal variate. In our experiment, we tried more the smoothing and other pre-processing method, but this method is not give good results. So we select only these three methods for publication. The substitute first, second derivative, multiple scattering correction, or standard normal variate. Because we use the integrated pair and the data can be some needed to scattering correction. Internal defects, for internal defects, we use the pixel component analysis, partial least square distribution analysis, and percent of oil content, partial least square regression. From there, after that, we use some feature variable selection method. We use some method to select the important wavelength, to make the online system for the quality assessment of intake macadamia nut. Here the feature selection method, the competitive adaptive reweighting sample method, random frog method, variable importance projection method. For the find out the effective wavelength, selection of the feature wavelength, we use the three methods. Here, figure of merit for the classification method, we use the accuracy, sensitivity, specificity, and the prediction model. Use the regression coefficient, square error prediction, and RPD, and RER, range error ratio, or ratio prediction deviation. We use these merit of figures of merit for the evaluate our model. This is the spectra of quality of intake macadamia nut. This is the nut spectra 345 nut spectra. This is the red color shows the average of the spectra. Here the spectra is the NIR zone 1000 to 1650 nanometer. And we use the relative transmission of the spectra. Here the second derivative spectra, you can see some stroke decline is around the 1100, and here 1310 nanometer associated with the third and second overtone of the CH3 bond. For oil, around the 1200 nanometer is reported to be associated with the second overtone of CH2 crashing. Here the right side figure, you can see the good nut and bad nut related transmission. The good nut related transmission is the low and bad nut related transmission is high. Also show the wavelength 1000 to 1650 nanometer. Using these data, we make the model. Using this spectral information, we make the model. This is the principal component analysis for good and bad intake macadamia nut. You can see this is the PC1, PC2, PC3. 3 PC needed to describe the most variance. 99.73% of variance showed the using 3 PC. The PC1 covered 96.55, PC2 2.06%, PC3 1.12%. Here you can see easily we can differentiate some sample, some good sample, bad sample, but some sample of good bad macadamia nut is overlapping. not easily separated from the PC analysis. So we went to the some classification model like PLS. Here the PLS DA, principal partial least square discriminant analysis model. Here the prediction result. The measured sample, one is the say good, two is the bad, and this is the discrimination line. Here some good sample is the classified is the bad, and some bad sample, no bad sample is classified as the good. So here the result PLSDA, if you full spectrum, if you use full spectrum data, the whole range, if you use the sensitivity 89.7% and specificity 100%, because the no bad data is selected for the good one. And MCC accuracy is the 93.1%. Number of wideband, here the 220 nanometer. If you use the future wavelength selection, here we use the CARS, random frog, and BIP, variable important projection. Here, if you use this feature wavelength selection, only CARS the 30 important wavelength selected, 29 for RF, and BIP is the 35. From here, you can select the CAS, PLSDA, CARS would be the good result, 87.3, 191.4. And the number of wavelength is the 30. If you see the 91.4, the whole spectrum is the 93.1, here is the 91.4 accuracy. But we select the CAS model because it contains the only 30 number of wavelengths. Here full spectrum 220 wavelength. It takes a lot of time, but 30 wavelength is take the less time. For online application, if you want to use, you need to use the CAS method. This is the CAS PLSD model has sensitivity 80.73% and 100% specificity. Overall accuracy of the PLSD CAS method is 91.4%. Here the prediction of the oil content, how to oil prediction range. This is the black color show the prediction range, the calibration and prediction sample we can show. The oil content percentage is the 62 to 78%, the range of the oil content of the macadamia nut. Here you can see four model, full wavelength model, and some oil feature variable selection model. From there you can see the PLS CAS model is good, good performance. The 0.88 prediction coefficient and the square error prediction 1.15%. And only number of wavelength is the 27, and latent variable is the 8, and the REE is the 14.95. So we can say NRS spectra in the range 1000 to 1650 nanometer can predict internal defects and oil content of the internal macadamia nut. Base simplified model PLSD CARS had accuracy is the 91.4%, and PLS regression CAS method prediction coefficient is the 0.88 for oil content prediction. We can say NRS spectra integrating sprayer plus based free process spectra and based simplified model, we can predict the internal quality of macadamia nut. Further, this model we need to apply the online system. Unfortunately, I have planned to apply the online system, but my studying is finished. I need to back my country, and now this work is continued to another researcher. This research is carried out in the Zhejiang University in China. Here another study. This is the NRS spectroscopy. Here I will show one application. This is the hallucinant soluble content of garlic of high spectral imaging. Garlic is the important, most commonly used vegetable due to multitude casino made utilizing their pungent flavor and odor. This is the garlic. I need to show garlic. Who is the garlic? This is the garlic. The garlic, sorting of garlic based on the external and internal quality such as size, color, pungency, and soluble solid content. In South Korea, this study is content in South Korea and it's published in the Journal of Agricultural, Food, and some environmental newspaper is around 4. In South Korean people consume a lot of meat. So each meat they eat on garlic. So the garlic pungency, the water and flavor is important for them. So we want to measure, okay, which component is the measure the garlic, water and flavor. The allicin is the main responsible component for the characteristic water and flavor of fresh garlic. And low soluble content will produce bitter garlic, while very high soluble solid content will result in tasteless garlic. So we need to find out the low soluble solid content and allicin. The extractive method is only assess the internal quantity of garlic, allicin, and soluble solid content, provide information limited part of foods. If you want to measure, you need to destructive method. No method for internal quality of garlic now is used for allicin and low soluble solid content non-destructively. We thought the hyperspectral imaging can provide non-destructive methods suitable for use, measure the sample allicin and soluble solid content and the whole garlic. So in this research, we use the hyperspectral imaging system. Here, the objective to predict the allicin and soluble solid content garlic cloves, not whole garlic cloves, using the hyperspectral imaging technique with indirect lighting system. Because why you use the indirect lighting system? I will tell the later. Develop independent allicin SSC prediction model, select the feature wavelength to predict allicin and SSC using the variable importance projection technique, create chemical image for visualization tested parameter for garlic based on the feature wavelength. Number of garlic clove, we use the 85 garlic cloves and weight is the 5 gram around. This is the garlic clove. We measure the indirect lighting system because garlic clove surface is the shiny. It the reflect the light. It makes some you can say some light, polarized light you need to use to. But a hyperspectral imaging, if you to use the polarized lighting system, it makes the expensive system. So we use the indirect lighting system. Here we use the lighting dome. On dome, then diffuser. We use the halogen light, in the dome, then reflect the light in the sample, and the reflection light will collect from the spectroscope and camera. To avoid the reflection of from sample, over reflection. So here we use the spectral range, the 894 to 2500 nanometer. Spectral resolution is the 5 nanometer. Image size is the X and Y is the 380 and 5 pixel. Number of bands 275. This is the lambda 250. And exposure time is the 40 milliseconds. Number of light, we use the 4 transition halogen lamp. Each of the 100 watts. We use the indirect lighting system using hemispherical dome. Here the sample is the moving in the translation stage. This is the transporter conveyor belt. The sample is moving, is the line scan camera. Allicin measurement, we use the SPL system carried out by chemistry department, DASN. And the soluble solid content, we measure the soluble solid content using a refractometer. First filtered the garlic juice 250 micrometer steam, then soluble solid measure using refractometer, recorded the soluble solid data individual sample. This is the information for reference measurement. Maximum 33.6, minimum is the 6, average is the 20.5, and soluble solid content 42, and minimum is the 28, and average is the 35 nanometer. This is the log diagram, how to we analyze the sample. Garlic sample, take the image acquisition, hyperspectral image, and calibrate image. We correction the image using the raw, dark, and reference. As a reference, we use the white reference. Then ROI selection, which region we will take the image. ROI selection. Then spectral data, from ROI, we extract the spectral data. Then derivative. The spectral treatment derivatives. Then spectra is divided into the 2 parts, prediction and calibration part. And calibration model, good, and prediction model. Then the good model, then we select the feature wavelength using the variable importance projection. From feature wavelength, we use the optimum feature wavelength and the here image, calibrated image at optimum wavelength, which wavelength we will use the maximum intensity image. From there, image boost processing, then we will get the chemical image. And hyperspectral, if you want to, the chemical image is the most important to show the different chemical component, the sample, whole sample intensity. And you need to know the image processing. Also, you need to know the spectra processing for hyperspectral imaging system. Finally, you will get the chemical image. This is the flow chart we follow to analyze the data. We use the software MATLAB 2015A. This is the spectra of garlic. That's the pre-process smoothing spectra of the garlic, 1000 to 1700 nanometer. Peak is around these 2 nanometer associated with the second overbond CS bond and first overbond OS bond. And the CS bond is very much related to the sugar content allicin. Is the OS related to the allicin. This is the reference value of the allicin and soluble solid content. The number of sample 5 to 10 is the allicin is the this is the calibration prediction we divided to the sample 21, 90.3, 35, 35.5. This is the PLS regression model for allicin and SSC. We can see the regression coefficient, the 0.96. Have the for sugar content, the 0.93. The standard error of calibration 1.1, prediction is the 0.89. By 90% confidence with PRT, there's no significant difference between measured and predicted allicin and SSC value of garlic cloves. Here, the prediction is the 0.93 and the square error of prediction the 25 to 292 unit. So we use the feature wavelength selection. Here the BIP score, wavelength and BIP score, variable impedance projection score, the for allicin and the SSC. Using this method, the BIP score threshold the 0.1, greater than 1 is good. So we select for the we select randomly check and we select the 1.1 and 1.3 for allicin and SSC. This is the wavelength we selected, the BIP. This is the dashed line show the second derivative of the spectra, reflectance spectra, and the red color is the show the selected wavelength. This is the color is the show the selected wavelength for SSC. So we reduce the value variable 121 to 33 for allicin prediction, 122 to 24 for SSC prediction. So using this wavelength, selected wavelength, the PLS BIP model for allicin SSC, you can show the prediction model 0.97 and for SSC, the prediction coefficient prediction 0.87. The allicin is lower than that of the model developed with all the variable, but variable reduced the 72.7%. There 121 variable, here only 31 variable. SSC is slightly lower than the model developed using the wavelength because here the little bit higher, but here is the lower, but reduce the wavelength. If you want to online system, in the feature wavelength selected wavelength take the less consume time for the analysis and taking the image. So feature wavelength is important. This is the chemical image. From the chemical image, you can see the higher distribution of the central part. Here, the higher the central part, you can see the yellow color, the higher central part, 1.1%. Lower to the peripheral area of the food, the allicin. The SSC showed the uniform distribution of the sample. So from the chemical image, if you show the chemical image, you can easily say, okay, this part is the bad, so I will not eat this part. This part is the higher, this is the higher higher SEC 14.7. So I will not read this part because this is bitter part of the garlic clove. So from the chemical image, you can easily you can differentiate the good part and bad part from your sample. So finally, we can say spectral ranges of 1,000 to 107 nanometer can predict the LSC and SSC garlic crop. Most accurate prediction model, we can square error of prediction 2.52 into 10 to the power 4 AU for LSC, and for SSC 1.41%. PLS-BAP model reduced the 32 to 24 barrier wide band, and the lessen the model complexity for LSC and SSC prediction respectively. Chemical image show the pixel distribution of LSC and SSC in the garlic clove. So finally, we can say that if we use the feature wavelength and PLS-BAP model, we can easily predict the LSC and soluble solid content of garlic. So finally, final slide, I will say some challenges and future work in this field, some challenges that should be considered in future studies. Reflectance mode is commonly used for the spectra and image acquisition. Challenge to use this mode to achieve accurate analysis for round shaped food and shiny foods. So we need to think about. Also, we need to think about every time for NR spectroscopy, you need to standardize. You need to standard variables to standardize the instrument before use. Application of hyperspectral spectral range, UV, shortwave IR, and mid IR are very limited. Hence, the purpose of the spectral lens remains in AGNIA. Still, don't know about this area for the spectra for the agriculture product. Combination spectra spatial information should be conducted using data fusion technique. Image and spectra, both you need to combination. Image and spectra, both combination can give the good result also. You need to data fusion technique used for analysis. Challenge for reducing computation cost and system performance. Currently, it's system expensive and it's challenge to reduce their cost. You need to less expensive because hyperspectral imaging system, if you want to buy, it's around the $20,000 around if you want to good system. So it's a little bit expensive. It is challenge to reduce their cost. Also, most success of hyperspectral is mainly in laboratory. It is translating laboratory result to industrial application is challenging. So you need to think about this one, how to this result to apply the industrial application. That's all my presentation. I use the reference from this reference used in my presentation. Mainly, I make my presentation using this reference, and I acknowledge to my full life my fellowship, the Canadian Commonwealth Exchange Program, ECPSC Fellowship, Japan Government Monobusu Scholarship, BK21 Postdoctoral Research Fellowship for Korea, International Postdoctoral Exchange Fellowship Talent Introduction Program for Zhejiang University, Bangladesh Agriculture University, University of Saskatchewan, Kyoto University, Chungnam National University, Zhejiang University. I would like to thank my mentor, my supervisor, and my student, my fellow colleague to help me to study. Thank you very much. Thank you for your kind attention.
Okay, thank you, Professor Rahman, for your very inspiring and nice presentation. Especially you, share us about NIR spectroscopy for the one type of vibrational spectroscopy as example, very detailed, and also you mentioned about the potential application of hyperspectral imaging, not only the theory, but also you mentioned about the latest application, and that's very nice. That's already published, very nice in the very high ranking journal. Okay, thank you, Professor Rahman. And now we have question and answer session. So yes, we have about 1 hour for this session. So please, any participants who want to ask Dr. Rahman Professor Rahman, you may deliver directly. Raise your hand, or maybe you can also write the question in the chat box. Okay, please. Anyone? So maybe waiting for a question for participants. I have a question for Professor Rahman. It's very interesting that you mentioned about the portable spectrometer, especially you also include the use of integrating spare, because now in our university also we apply the portable spectroscopy for NIR with integrating spare. So how about the practicability using integrating spare for? I mean, now we also set up the portable and integrating spare in a laboratory, but how we apply maybe yes, in the future
practical application,
using integrated spare. Yes.
Practical integrated spare is little bit challenging work. I see one online system in China. They use the integrated spare, but this is the time is very slow. It takes long time to finish the result. So it's still is the challenging to use the integrated sphere, the first automation online system. So if it is better to have the integrated sphere in experiment, but if you have no option, then you need to think, okay, because my sample is the very different kind, because the hard thick shell and the shiny surface, so it's very difficult to penetrate light. Also the reflection light is not good, so we use the integrated sphere. Now my fellow researchers are thinking about how to adjust the integrated sphere in the online system. They design some system for integrated sphere. Hopefully they will apply, but it's difficult, it's challenging work.
Okay. Yes, especially because we use integrated sphere to intensify the light penetrate to the sample. But yes, of course, in the application, maybe if it's the integrated sphere mounted to the spectrometer, it will be also hard to configure the system. Okay, maybe later. I think yes, of course, it is very challenging. Now we are applying the integrated sphere to intensify the spectral data for quantifying the very low amount of chemical compounds, such as in coffee, you know, we have CZA or something like that. It's very low in concentration, so we use integrated sphere to intensify the spectral data. But of course, we are now still thinking how to apply this in the practical application, because integrated sphere is really challenging now. Okay, thank you. And of course, other question maybe for other participants, please. Any question? Professor Rahman is very active. As I mentioned, just 5 years after completing the PhD, he got professorship. Yeah, five years after completing PhD. So he completed PhD in 2015, and 5 years later, in 2020, he got a full professorship from Bangladesh Agricultural University. Okay, any question from students? Of course, welcome, please. Or maybe from faculty member from Lampung, or we have also here from Gajah Mada, from Sriwijaya, from IPB, from Brawijaya. Any question? Okay. Now we have one question in the chat box. Maybe I will ask Professor Rahman. From Johnny Firdaus. Okay. What is material or coating material was used inside the integrating sphere and diffuse dome. So what is the material you use?
Integrated sphere we brought. Thank you for your question. This is a nice question. And integrated sphere we brought from commercial market. This is the some coated already. But for diffuse dome, we designed that one, and I painted using the 100% near 100% reflexive paint. You can buy from the website. Some websites they are writing the 100% reflexive paint. So we buy this white paint that are 100% reflex, near 100% reflexive, right?
Oh, okay. What is the material? Something like
integrated sphere,
calcium
like the
bromide
steel.
or something?
What?
Something like a calcium bromide or something like that, or the
like the paint, bromide paint, like
Oh.
normal paint, the special paint
I
for
see,
the
I see.
100% reflective light.
So how about the reference? Also, the company supply the special reference.
For integrated sphere, they provide the reference.
Okay.
Reference sheet. Usually we use the sheet, and diffuse dome we design that one.
Okay. Thank you. How about the system? I mean the direction of the light source. You try many direction. For example, how about from the bottom part?
In diffuse light, we use the full light in the system. The all light is the 90 degree. Then the diffuse is there. Then this side.
Okay.
And the 45 degree up.
Now in our system, we use the lights, the high power lights from the bottom part.
100 watt, the same light.
Okay. Thank you, Professor Rahman, for your answer. So it's yes, of course, it's very interesting because now integrating sphere is gain popularity in vibrational spectroscopy because. Yes, maybe last 10 years, we have developed portability of the spectrometer. Now the research moving to the not only the portability of the spectrometer, but also the improvement of the other device such as integrating sphere to increase the intensity of the light. Or to intensify. Okay, very nice. Okay, other question? Maybe from students or from faculty members. It's very nice chance for us to directly meet and also discuss with one of the top researchers especially in vibrational spectroscopy and hyperspectral imaging. Maybe from we have also Dr. Dimas. Okay, Dr. Dimas, you are also one of expert in spectroscopy and hyperspectral. Any question for Professor Rahman? Dr. Dimas from Brawijaya. Any question? We have also Dr. Okay. We have we have also Ibu Handayani from IPB University, and also I think we have also Dr. AP from Gajah Mada. She's also an expert in spectroscopy. Okay, any question? Okay, if not, I have another question. Waiting for our participants. Okay, my question is, so you have already mentioned about the spectroscopy and also hyperspectra. So if we want to make a research and then, yes, of course, depend on the sample or depend on the target of the chemical compound, for example, or target of the research. What is the quantifying something or maybe just classification? So if we have two options, using spectroscopy and using hyperspectral. Yes, of course, the price is also our consideration. So, do you have any other consideration? Which one is suitable, or which one is the priority for the selection? Which one?
Okay, and the first I say that the spectroscopy, the detector is the point spot. The sample will get the point spot, but hyperspectral you will get the full sample. So if you have an option, you can select the hyperspectral imaging, because you can see the which part is the high content, high. You can easily select. So if you have no question about the cost and other things, if you have a two instrument, if you have a time, so you may go for hyperspectral imaging. Then you can select the feature wavelength. Then you can make a system, the normal machine vision system on other system.
I see. So for single coffee bean is very small. So maybe both is okay.
Both is
Especially for
okay, but
spectroscopy.
rice is the difficult for hyperspectral imaging. You need to the high configuration camera.
Okay, thank you, Professor Rahman. Okay, any other question from our students? Maybe it's very good opportunity to ask your question directly to our invited speaker. Any question from our students, or maybe for our faculty members? Okay. No question, not yet. If not yet, maybe another question from me. Okay, actually, maybe yes, of course, the future of the detection system is using low cost system, and also a fast system, and also of course on-site measurement is very important, because now some sample is very difficult to bring to our laboratory. We have to bring our device to the sample site. So in your opinion, what is the direction of the spectroscopy, or maybe hyperspectral? Which one will be appropriate for very fast measurement? Yes, low cost is very important, affordable to, especially for us. Developing country is very yes. We have to consider about the cost, and also of course the suitability we can bring to the sample site. Which one is maybe?
Yes, I definitely say this is the spectroscopy, portable spectroscopy. Now is the well-researched and well-established technology, and you can find out also low cost around the $1,000. You can find the portable spectroscopy. Easily you can move to spectroscopy to the sample. But for hyperspectral imaging, in last decade, 2010, started to research in agriculture sector. Maybe it will take another 10 to 15 years to develop. So now in this time, if you want to do practical application, you need to go to NIR spectroscopy. Then if you want to machine vision system, but hyperspectral system still developing, not for practical application still.
How about the UVVs?
UV.
I mean, UVVs maybe is more affordable.
Yes.
I mean,
more affordable, but it's expensive to hyperspectral imaging system.
Udah. Okay, because now we are thinking also about if we can move to other regions such as UVVs, maybe in the device, maybe more affordable, or maybe not only in the device, but maybe in the development of the system, the light source, maybe the LED is cheaper in the UVVs comparing to the LED in NIR, for example.
light source is okay. Light source halogen you can use the NIR also NIR zone, but the detector is the main problem.
Oh, okay. Detector is main problem.
Main problem. Halogen light you can use, but detector is the main problem.
Okay. Yes, we have to think also the
In visible regions you cannot measure the chemical composition. It's very limited.
because your research is also before is in UVVs.
Yes, my PhD in the UV.
UV, so
UV, but you need to transfer to imaging system if you want to go UV.
Okay. It's very nice. You have experience not only in AI or UV, NIL, and hyperspectra. So that's why you are expert in this area. Okay, thank you. Okay, thank you, Professor Rahman. I think we are waiting for question from participant, but I think your explanation is very clear. So that's why no question, maybe not yet. So, but maybe later, if they have question, you can ask and send email to the committee, to us, and then we can send a question to Dr. Rahman.
Easily,
okay.
anyone can contact with me. This is my address.
Okay. Thank you, Professor Rahman. So please, to all participants, you can see in the chat box, Professor Rahman has
anytime any question.
Yes.
Welcome.
Email
No problem.
on WhatsApp. Yes. Because,
WhatsApp is okay also.
Okay. We have one question from Dr. Warji, our secretary. What is the vibrational spectroscopy can be used to evaluate the quality of inner products? For example, fruit damage due to fruit fly attacks where the outside is good but the inside is damaged. Is it possible or not? Yes, in Indonesia we have mango. We have mango.
Mango. Yes, in our country we have a lot of mango.
Yeah.
There's also a lot of mango. Yes, it's possible, and spectroscopy also possible. But if you go to spectroscopy, is good. But if you want to other such spectroscopy, if you want to the sound system, this is also good.
But because the target is not chemical, the target is the fly,
damage.
Inside, the damage. Okay.
So sound system may be also good
because the volume is different.
Yes.
How about the terahertz?
I have no idea that one.
Okay. Because the water content, I think maybe different. The water content is different because the fly inside maybe make some hole, and maybe the water content is different. It's very interesting. So also you have such kind of injuries. I mean the damage outside is okay. Very small.
Yes.
But
in
inside,
our country, mango is the main problem. This one.
Okay. So
we have a lot of mango.
Yes. In mango season in Indonesia, we have such kind of problem. So when we buy the good mango, but when we cut,
inside is the some.
Yes. Okay. So do you have any experiment or research about that already?
Last year I back to here, so I started. Now I am working in some seed viable and viability. I have a plan to establish a sound experiment system.
Okay, very nice. Also, we have durian. Durian, do you know durian?
Yes, durian. The thick outer side.
Yes. Durian,
mango sting also thick.
So the spectroscopy may be difficult to see inside.
So if you want to only inside internal quality, internal decay, so at first it's better to try the sound system.
Okay, sounds good. So I think we have Dr. Waluyo here. Dr. Waluyo is our faculty member. He got a PhD from Missouri University, USA, and his PhD is about sound ultrasonic. Ultrasonic. So ultrasonic is, I think, about sound. And also Dr. Warji is also got a master degree from IPB using ultrasonic. So it's very interesting.
Yes.
If you collaborate with our faculty member, developing ultrasonic system for not only spectroscopy but also ultrasonic system.
Okay, sir, I will contact with you.
Okay. I think it's very good point to collaborate research in the near future. Okay, any other question? So I will check in the chat box. Okay, I think not yet, under no question. So maybe I think if not, so maybe we can finish this lecture. Thank you to Professor Rahman for this interesting lecture. So maybe one I recommend to all of the participants, please you can see it in the chat box. There is link for the participants to get the certificate. Please you can click and then you can automatically got the certificate for this international lecture. So thank you, Professor Rahman, for your presentation, for your sharing in this international lecture. So hopefully, yes, in the near future, we can collaborate to use vibrational spectroscopy, hyperspectral, or maybe ultrasonic to make a joint research together with Lampung University. Thank you very much, Professor Rahman, and please big hand for Professor Rahman. Okay, thank you,
Diding. Thank you, everyone. Thank you,
okay.
Andreas Mara, sir.
Thank you very much. Okay, that's all for today lecture. So and then thank you very much for your attention, for your question to all participants. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. Waalaikumsalam.
All right. Thank you, Dr. Diding Suhandi, STPM Ager, and Mr. Professor Dr. Anisur Rahman for the insightful presentation. Well, the next is awarding certificate and photo session. For the attendants, may turn on your camera, please, and have a smile when the operator take the photo.
Please all turn on camera. We have a photo session.
Okay, let's start. 1, 2, 3, smile. Okay. Next. 1, 2, 3, smile. Okay, thank you very much, everyone. Well, those are the agendas that have been implemented. Hopefully, it will be useful for us. Before we officially end, please note that the next international lectures maybe will be held soon. Finally, representing all of the committee, I would like to say thank you for your participation and please take my apologies if there's a mistake. In the end, I'm Krishna Bayu Aji signing out. Thank you and see you.
Oke, terima kasih Pak Pur.
Oke, terima kasih Pak ini.
Terima kasih atas kehadirannya. Terima kasih semua Pak Pur, Pak Diding, Pak Wadi, dan Bapak Ibu peserta semua.
Ya.
Ini bisa bermanfaat.
Nggak tahu.
Walaupun
dia email ya.
Gunakan sekarang, tapi mudah-mudahan ada manfaatnya. Bu Evi, terima kasih bisa bergabung. Kemudian Pak Murad tadi juga saya lihat ada. Terima kasih Pak Murad dari Unram.
Terima kasih Pak Sandi.
Ya, Pak Daniel.
Semangat.
Insri, terima kasih kehadirannya. Bapak dari Brawijaya tadi juga terima kasih. Lupa saya namanya.
Betul, terima kasih.
Ya, mudah-mudahan kita bisa bertemu lagi di acara kuliah internasional ini. Bulan depan kita masih ada dua lagi pembicara yang akan kita hadirkan dalam kegiatan internasional lecture ini. Terima kasih sekali lagi Bapak Ibu, dosen dan para peserta. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh. Matur nuwun Kiai Sandi.
Ya, turun. Sukses Pak Sandi.
Terima kasih ya Pak.
Pak Tamrin udah absennya tadi ya?
Ada Pak.
Ada
Ya,
di
berarti
chat Pak.
otomatis ya.
Makasih, izin lab dulu. Mau lanjut
Oke.
rapat. Ya, makasih Pak Budi.
Ya, terima kasih. Sama-sama. Sudah bisa. Ya, sudah bisa keluar.
Nggak boleh keluar, En.
Nggak boleh keluar katanya tuh. Pak Amin. Pintunya dikunci. Nggak bisa keluar, pintunya dikunci.